2.7 is word problems. We are not doing that. That is going to be at the end of the semester. I'm throwing them all into one unit so that you just have applications to focus on. And you can also see kind of what your grade is at and prepare accordingly. We'll cover quadratics. This is review. Operations on function and composition. This is new. Function inverses. This is new. It's one of the first times you encounter material in this class where you had not seen it before. Transformations you've seen before, okay? This is new. And so if you do miss class due to CNA people, please raise your hand. Just one, that's all we got. Just one CNA person. Okay. When you miss class, this is the one that it hurts a little bit more, okay? So usually November, end of October is kind of that time where, you know, I guess CNA becomes a little bit more challenged. So let's make sure we talk about before we go over that. But the cool thing about it is that as we look at this piece, it's going to help prepare us for these applications because applications occur when we look at extreme values over a given interval. And so parabolas fit right into that, which is what we're going to look at. But if you notice, this has an extreme value here and an extreme value here. We call this spot right here a local maximum. Not because it's the largest spot on the graph entirely, but it's the largest spot on the graph in that immediate region. And then we have this spot down here, which is the local minimum. And you can see that it's not the smallest spot on the graph, but it is smaller than everything else around it, right? Now, a lot of people talk about math, they say, when are we going to use this? Well, I told you, we have an applications unit we're going to do right at the end of the semester, and you'll see a lot of the applications. Challenges is sometimes we do the application, people say, well, it's too tough, I don't understand it. Let me put it like this. If you guys have a business, do you like to maximize profit?
Yes.
Yeah, well, that tells you how to maximize the profit. Do you like to minimize cost? Yeah, that tells you how to minimize cost. So when you get to college and if you decide you want to go into business and be an econ major, there's two types of econ majors. It's very simple. Those who understand calculus and those who don't. Those who don't understand calculus, they take short calc and just push their way through real quick. But those who understand calc, okay, they see their econ major all the way through and take even more classes. They understand the raw design of the maximum and the minimum. The application of the maximum and minimum is incredible in mathematics, and that's where we want to take you eventually. So let's start that introduction to maximum minimums by looking at two things that have maximum minimums, namely quadratics. Quadratics can come in two forms. This is called vertex form. Vertex form is what we're going to look at next week, Wednesday. And you already know vertex form. We've been graphing it all the time. If you notice the H on the inside is the inside, so it's a horizontal shift. The K on the outside is the vertical shift. Very simple. You could graph one right now. You're doing it in your lesson, no big deal. This is what we call standard form of the parabola. And when you have the standard form of a parabola, we want to find different aspects of the parabola by using A, B, and C. So suppose that the graph of the parabola looks like that. Does anybody know what we call this spot of the parabola? Vertex. Anybody know the equation that we use using A and B in order to find the vertex? Negative B divided by 2A. Does that sound familiar? You are never allowed to forget that again. Why? Because you know it. Every single one of you knows it. You're like, Mr. Again, stop it. No, literally you do. Watch. Everybody knows negative B plus or minus the square root of B squared minus 4AC all divided by 2A. You all know that, right? Yeah, well, there's negative B divided by 2A. Like the vertex is built into the parabola. I mean, it's right there. It's part of the quadratic formula. So you'll never forget that. Trust me, now that you've seen that. How we get the y value is we do f of negative b divided by 2a, and that will tell me the y value of the vertex. Once we find the vertex, it's easy to identify this thing. Anybody know what we call that? Axis of symmetry. Axis of symmetry, is that a vertical line or a horizontal line? Vertical line. Vertical lines have an equation of? X equals, thank you. What do we call this spot on the graph right there? The y-intercept. The y-intercept happens when the x value is equal to 0. Notice if we plug in 0 for x, we just end up with c. Agreed? So therefore, the y-intercept is c. And finally, we have these 2 points right here, and those are called the x-intercepts. We've already found x-intercepts. We did a lesson on finding different types of intercepts. We did a lot of quadratics. You have 2 options here. Number 1, you could factor. Or number 2, you can use a quadratic formula. Tell the person next to you, did you type the quadratic formula into your calculator from 3 weeks ago? Did you or did you not? Go. If you didn't do that, that's something you're going to want to do. We do. Yeah.
No.
So we're going to go ahead and do 2 examples, and you'll be set to do parabolas. This should be a review. Okay? That doesn't mean that it's easy, and it doesn't mean that you won't make a mistake. But I want you to know that the first problems you get on the test are the same problems you had back in 8th or 9th grade. Okay? So let's get those right. Let's save our mistakes for the new stuff that we cover, not the old stuff. So we're going to sketch this graph. We're going to determine the direction, the vertex, the axis of symmetry, the y-intercept, and the x-intercept. If a parabola is in standard form, then I will ask for those five characteristics. What direction is this parabola, up or down?
Up.
It is up. How come?
Positive.
Because the 2x squared is positive. Thank you. Now I have the vertex. Notice in this situation, I have A is equal to 2, I have C is equal to negative 8, but I have B is equal to 0. There is no x, so therefore B is 0. So as I set up the equation for my vertex, I have negative B, or negative 0, divided by twice the A value, and I get 0. 0 is the x value of the vertex. In order to come up with the y value, I plug it in. 2 times 0 squared is 0, minus 8 is negative 8. The axis of symmetry is easy. It is always x equals the x value of your vertex. If you write 0, I'll take a half a point off. You have to write x equals 0. The axis of symmetry is not a number. It is an equation for a line. X equals 0 is an equation for a line. 0 is not a line. Everybody agreed? It may sound like I'm getting technical, but it's just really hard if it's not accurate. The y-intercept is just the c value. It's negative 8. So then we find the x-intercepts. And in this situation, finding the x-intercepts is nice and straightforward. 0 is equal to 2x squared minus 8. To find the x-intercepts, set the y value equal to 0. If it factors, factor. You can always use the quadratic formula. Without a doubt, factoring is a quicker option. We factor out the 2, x squared minus 4. And so we have 2 times x plus 2 times x minus 2. So my x-intercepts are positive and negative 2. Drives me insane when some people just write down one x-intercept. You know that there's 2 of them. It says x squared. So I go ahead and graph it. I'm going to make a 2, 4, 6, 8. Man, I saw those tennis girls this morning headed off. They were like dancing in the parking lot and jumping around. And do they like consume like energy drinks in the morning, do you think? You got soccer tonight. Doubleheader, right? Exciting. Good luck to all you. I plot the -8. Parabola goes up. It's nice and steep. There we go. Tell the person next to you, scale 1 to 4. How confident are you about doing a problem like that on tests? Go ahead.
Wait, so, oh gosh, I probably wrote that.
Against, did you go?
This is the equation we need to use. What's the equation we need to use?
Okay, second example and our final example for the day. What makes this problem a little bit more difficult? There's a fraction. You guys need help with the fractions. Okay, I've gotten to know you pretty well. And I know you're like, well, hey, Mr. Guess, you could use some work on some stuff too. I know I could. I've been working on the hair thing for quite some time. Just haven't found a solution yet. So I'm not trying to pick on you. I'm just saying that that's a weaker spot for us as a class is we need the exposure to the fractions. Be ready to see them during this unit. So I look at that direction, up or down? Down. I'm going to do the easy ones here. I'm also going to do the y-intercept. What's the y-intercept? 3. Look at that. A couple points right away. Great. I'm going to do the vertex, so I take -b. So -b is +6 divided by twice the a value. What's twice the a value? -1/2. 6 divided by -1/2. I don't ever divide by a fraction. I multiply by, and I get -12. BK?
It's making sense now. This is the -b over
2a.
2a.
Yep. So there's my vertex for the x value. Once I know the x value, I can state the axis symmetry. The axis symmetry is x equals -12. What about the y value? How do we determine the y value? Plug it in, right? I don't know about you guys, but I'm not all that excited about plugging this in to that without my calculator. You guys want your calculator? So let's use our calculator. Go ahead, take that out. Okay, one thing that's beautiful about your calculator is it understands the order of operations. So as you plug in -12, make it very simple. -1/4 times parentheses, -12 squared. Is it plus or minus 6x? I can't remember. Minus 6 parentheses -12 plus 3. So notice that all I did is I typed the exact function, and all I did is I inserted -12 with parentheses. Remember my insistence on that we use parentheses yesterday when we were doing our odd and even functions?
Yes.
Again, when you substitute a value into function, use your parentheses, and that way it takes care of the negative as well. I just press enter, and I get a value of 39. So I could start making a little bit of a graph, and here's where people really start to make connections. And we're going to allow you to do the same. I'm going to make a 40 by 40 graph here, We go 10, 20, 30, 40. Anybody have a really good supper last night? Try and decide what to do for supper tonight. I just don't know. I'm going to plot negative 12, positive 39. That goes right there. And the axis of symmetry looks like that. And the y-intercept is at positive 3, so it's going to go through a spot like right there, which means I would have one reflected over on the other side that would go like right there. So based off of my graph right now, based off of what I've drawn here, talk to the person next to you. What would you estimate? Just estimate. What would you estimate to be the x-intercepts? Make a guess. Go ahead. Make a guess. What do you think they are? Go. How about 1 and negative 25? Does that sound reasonable? Does everybody agree that one of them should be positive, but probably for sure less than 5? Does everybody agree that the other one should be negative, but probably for sure less than like negative 30? Or I mean greater than negative 30? So let's see what we get for our x-intercepts as we try to plot this. So that's not my actual graph. I just did it to try to show you guys. So let's go ahead and find the x-intercepts. That might factor, it might not. But in this situation, I can take y and set it equal to 0. 0 equals negative 1 over 4, x squared minus 6x plus 3. This is where your algebra skills need to take over, okay? Again, you are experts at algebra at this point. I hate that. Everybody agree? Make it simpler. Somebody tell me how to make it simple. Multiply everything through by negative 4. Thank you. Why is Brecken choosing multiply everything through by negative 4? Get rid of the fraction, right? Yeah, so now he's got 0 is equal to x squared plus 24x minus 12. Well, that looks like something I'm more ready to deal with. Are there two numbers that multiply negative 12 that add to 24? Yeah. There are not. And so therefore this does not factor. Now, on the test, you can use your calculator to find the decimals, but you also must list your answer in simplest radical form. In order to find these answers in simplest radical form, we must go to the quadratic formula, which is negative b plus or minus the square root of. We square b. Anybody know what 24 squared is? 576. So it says breezy minus 4 times 1 times negative 12. All divided by twice the a value. So we got negative 24 plus or minus the square root of. Shoot, what's 576? So it's minus a negative, so it's going to be plus on the inside. Everybody agree? So I got 576 plus 48. So what is that going to be? What do we got? 624? 624. Divided by 2. Is it possible that the square root of 624 reduces? It is. Anybody know the perfect square divides evenly into 624? I don't either. All you can really do is just guess. 624. Somebody give me a guess. I heard 16 by somebody. You're right. It goes in 39 times. So we got 16 and 39 there. Negative 24 plus or minus 4 roots of 39 all over 2. 24, 4, and 2 are all divisible by 2. So I divide them and I get negative 12 plus or minus 2 roots of 39. Now you got two options. You can do the first option, which is negative 12 plus 2 roots of 39. And you get 0.489. You get negative 12 minus 2 roots of 39. Whoa. And I get negative 24.49. So I've got 0.49, negative 24.49. If you notice, that's not too far off from what my guess is. Seems like things are reasonable. So I plot 0.49, so it's just on the other side of the x-axis. I go ahead and plot negative 24.49, just off from that dot there. And now I have a very, very good graph. The other way that you can find the decimals is pretty simple. Do you have yours plugged in?
Yeah.
Bryce has them. I'm just going to show you here. If you did your quadratic form of your calculator, go ahead and follow my lead. I'm going to press program. It says quad form. I press enter on quad form and enter to start it. For A, I enter the negative 0.25. For B, I enter the negative 6. And for C, I enter 3. And it gives me exactly those 2 decimals. Now, some people are like, well, what's the big deal if all I have to do is just enter that? You guys, there's going to be times later on in this course where you won't have to find that at all, and you won't have to do all that work. You can just straight go to your calculator right away and spit the answers out. Okay, great? Yeah. So you're going to go to, on your calculator, you're going to hit program, and then it's going to say quad form, and press enter on quad form. And then you're going to press enter again to get the A to pop up, and then just enter your values. You good now? Okay, good. So let's check out our homework here. You have this to work on. Oh, they're out of order. Did I really do that? Stupid. Okay, I accidentally put vertex form first. We're doing vertex form on Wednesday. You guys are doing standard form. I'm sorry about that.
It is okay.
Will you forgive me?
Yeah.
Thank you. Now, I don't think that you have to do these parabolas right now, but I do think you have a problem if you wait until the Tuesday we get back from break. You get what I'm saying?
Yeah.
So I want to get you to have other things to work on, but don't put this off too long. And again, this should be reviewed. So, rest of the time is yours. I'll come around and help you.